All right, this is lesson 1.9 for Algebra 2. Today we're going to be talking about parent functions. If you think about any kind of function that you can graph, a linear function, which is a line, or a quadratic function, which is a parabola, each of those, a linear or a parabolic, those are going to be families of functions. So a parent function is just the most simple form of a function. So with the defining characteristics. So here's the parent functions that we're going to be studying. We've got constants, linears, quadratic, cubics, and square roots. So the parent function for each of them can be found in this column, or this row right here. So let's look at the constant family. So that would be an example of like y equals 5, or f of x is equal to 5. In which case, when you look at this graph on your coordinate plane, it's going to look just a straight line right there. So that may be at like y equals 5 or f of x equals 5. The domain in this is going to be all real numbers because the x's are all included, and the range is only at y equals 5 because the range is the y values. So where it intersects the y-axis would be at 0, 5. And that could be any y value. So it could be y equals -3. That would be a constant, and that is going to be the parent. Now a linear, generally when we look at a linear, we might say y equals mx plus b is how we associate a linear function. So the parent function is just going to be y is equal to x. So the way this looks on a graph is going to be going through the center. Whoops. I'll do my best to draw a line through the center. So the line is going to go through the center at a slope of 1, 1. All right, so that would just be x. So the domain is all real numbers, the range is all real numbers, and it goes through the origin. For a quadratic function, you might have y equals x squared plus x plus 0 or something like that would be a quadratic. Your parent is just an x squared. So what that looks like is on your graph right here, it is going to be a parabola that goes down and touches at the origin and comes back up. So your real numbers are going to be your domain. Your range is anything bigger than 0 to include 0, and it touches down at the y-axis. A cubic parent function would be an x cubed. All else would be translations of them, transformations. So a cubic, so if a linear is a straight line, quadratic is a parabola. A cubic starts down there, and it's kind of an S-y shape like that. Your domains can be all real numbers, your range will be all real numbers, and your parent function will go through the origin. For a square root, this is what your basic parent function looks like for a square root, starting at the origin and just going that way. So the reason for that is that you can't have a negative x on the inside. You couldn't do the square root of -5. So all our x values have to be greater than 0. And because of that, when you take the square root, you're going to get all y values that are greater than 0. And so it has to be in the first quadrant by definition for a square root. And it will start at 0, 0, so that's where it touches the y-axis. So let's identify some transformation of parent functions. There's a couple of ways you can do this. What we're going to start with is by using the graphing utility on our calculator. So we're going to identify the parent function for g from its function rule, and then graph g on the calculator and describe the transformation of the parent it represents. All right, so we have g of x is x plus 5. So just by looking right here only, what would you say the parent function is? Okay, so it's not just g of x is equal to a number, so it's not a constant. There's no squares, there's no cubes, there's no square roots, so this has to be linear. The parent function is a linear. So then if you graph it on your calculator, you go into the graphing utility part, and you put it in. This is the picture that you're going to get. So let's describe the transformation of the parent function. So if the parent function is supposed to be like right here, what have we done? We have done a vertical, because we've moved up, translation of 5 units. So you could say that this is a vertical translation of 5 units up. So in any linear function, all it really is it is a translation, either right or left, up or down, or even a flip in that transformation if you're changing the slope of the parent function of y equals x. So this one, if we were to identify the parent function from the function rule, if we're looking here, we've got a square, so that means that it is going to be a quadratic. When you put that into your calculator and you graph it, you get this lovely parabola over here. So its translation then, if you think about what the parent is supposed to look like, is where it's coming down and touching right here, all we've done is we've translated it 3 units to the right. We can also use just a data set to figure out parent functions. So in this case, I'm not going to give you the equation, I'm going to give you data from a table. So the way we're going to have to do this is we will graph the data from the table, not on our calculator, but on paper. We'll describe the parent function and then try to figure out the transformation that approximates the data set. So here's our graph. We're going to just set these up as ordered pairs. One thing to be aware of is that the more ordered pairs you have, the better picture you have of what your graph actually looks like. So for example, if I were to graph this first one at -4, 8, and then I were to graph at -2, 2, those could be a straight line. Those could be a linear function. It can also be a quadratic function. It could be a circle. It could be an ellipse. It could be a sine wave. There's lots and lots of things that it could be. So the more data you have, the better picture you're going to get. So don't just make an assumption after 2 points of what you got. Go ahead and graph everything that we have. So we're going to add our 0, 0 in. We'll graph our 2, 2, and we'll graph our 4, 8. So this looks like a parabola, which tells us that our parent function, generally the parent function is approximated as f of x, would be x squared. So if our parent function, let's say we had our parent function, we were wanting to see what exactly points would pass through that. So if x were 0 in our parent function, our y would be 0. If our x were 2, our y would be 4, not 2. So in the parent function, yes, it would go through right here, but if our x was 2, our y would be 4, so its point would be way up there. And if our x were 4, our y would be 16. Okay, so it's going to be like way up there. So you can see that the points, it looks like it's been a compression. We have a compression here, it's squeezing it. So if we look at that, what our points would be, so we have, if f of x would be 2, 4, and the one that we have is 2, 2, what's the difference between those? So our new, this one, we reduced it by half. So that would be like 2 and then 4 times 1/2 would give us our new point. So it looks like we are compressing it by a factor of 1/2. That would be an approximation of what it is that we're doing. Don't worry if that was a little confusing. I promise we'll have lots of practice on it. Hope you have a good evening, and I'll see you later.